Hello everyone, my name is Ryan Boyd.
And I'm Michael Manoochehri.
And today we're here for the Ryan and Michael Show. Welcome back. I think it's been a while. It's probably been over a month since we've last done the Michael and Ryan Show.
It's been too long.
Been too long. Been too long. So I miss doing it. Hopefully you miss watching it. Today we're here to talk about sensor data collection and BigQuery analysis. So we're going to go through a full data pipeline, an example pipeline of how to get data into the Google Cloud Platform and then analyze it with BigQuery. As we said, my name is Ryan Boyd, and this is Michael Manoochehri, and here's our Google Plus and Twitter handles at the bottom of the screen. If you have any questions after this event, feel free to reach out to us there. Of course, you should follow the Google Cloud Platform Developers Plus page as well. And during this event, though, if you're here live during the event, check out the Google Moderator. So on the Google Developers Live page, you should see a moderator embedded in there, and check out that moderator and ask us any questions that you have, and we'll take some time to answer those questions at the end. In addition, today, for the first time, we're going to be going through some of the Stack Overflow questions from the week, the most interesting Stack Overflow questions.
Yeah, and if you have some questions, we answer questions at the Google-BigQuery tag on Stack Overflow. So please post them there.
Yeah, so we answer those live, but we'll also go through some interesting ones on the show. All right, so let's dive into this. So first of all, we want to talk about the pipeline that we've built in order to get data into BigQuery for analysis. And this pipeline looks something like this. So we have, on the left-hand side here, this thing called an OBD2 adapter. OBD2 is the Onboard Diagnostics Protocol, version 2. And what it allows you to do is collect data from your car. So I recently got a new car. My last car was about 10 years old, a little over 100,000 miles, and decided to call it a day. So I got a new car, and I wanted to be a bit geeky with my car. So I wanted to get data out of my car, and then I figured out how could I incorporate this into a work project so I can have fun and get paid for it at the same time. It's always nice. And so this OBD2 connector allows me to do just that. It's like $15 or $20 on Amazon, pretty cheap. And basically it has a Bluetooth radio in it so that when you collect data from your car, you plug this into your car, it collects data, and using Bluetooth, it communicates that data over to my phone.
Ryan, I wasn't familiar with this until you started this project, but is that the kind of thing that mechanics use for like the telemetry from the car?
Yeah, exactly. So the onboard diagnostics connector, I think exists in pretty much all modern cars, and it's primarily used by mechanics. I think if you read the manual of my car, it does warn against using it for any hobbyist purposes. Don't tell my wife that. But it is primarily used by mechanics. They also, in some of the other cars, have more advanced versions of these connectors that allow you to get even more data. So this might be like 40 or 50 data points, something like that, that it pulls off. But it's pretty fun nonetheless, and it allows you to get data via Bluetooth over to my Android phone. I carry my Android phone with me all the time, so I can get data to my Android phone over Bluetooth. And then my Android phone has an app running on it that uploads that data up to App Engine. So it just makes simple HTTPS posts up to App Engine and uploads all of the data each time it's collected from the connector. And once the data is up in App Engine, I have a goal to analyze it. I really want to crunch that data, figure out how fast I'm going, things like that. So for that, I use Google BigQuery, of course. And so I need a way to get the data from App Engine to BigQuery, which we're going to talk about here shortly. One of the other things that I should mention here is, although I'm just collecting, in this case, data for my individual car, there's plenty of different use cases here for programmatic collection of data from sensors, getting them into the platform, the Google Cloud Platform, and analyzing them there. So we've talked, with a variety of different companies that have different use cases for sensor data collection, things like weather and other types of data, where from all around the world you can have these sensors that uploads data through the cloud platform. And since Google exists all around the world and has pretty fast connections, that's an easy way to upload data, and then you're analyzing it all in the cloud. So I even think, specifically with this car data, there might be great use cases out there for fleets of vehicles to analyze patterns of how those vehicles are operating.
It doesn't just have to be vehicles, as you said. Any kind of sensor that can make an HTTP post to the App Engine app can use this kind of system. And what I also like about this is it's so accessible. I mean, the device you were using to collect data from your car was rather cheap. You already have a phone and with Bluetooth, and it's something like a lot of people can do and actually code themselves.
All right, so this is the complete pipeline. Let us know if you've built. You can post something in the moderator or reach out to us in Google+ if you've built a similar pipeline for your own data. And we're definitely interested in hearing what you've built. So let's talk about now the application that we're using for the collection of data. So the application that we're using right now to collect the data is called Torque. We're using the paid version of this app called Torque Pro. Here's the screenshot from the Play Store. And what we're doing, this app basically does a whole bunch of stuff. It's written by this gentleman named Ian Hawkins. It looks like he's put a lot of time and energy into building an awesome app here. You can see here over 100,000 downloads. He's basically does a lot of displays and all, so you can use this as sort of your dashboard as you're driving. But for my case, I really just wanted the data. I wanted the data out of the application and up to App Engine. So it also has a way that you could specify a HTTPS URL to App Engine, and it just does very simple posts over to App Engine when each data point is collected. So from there, App Engine, we have a very simple App Engine app we wrote. I don't know, like something like a 15-minute App Engine app.
Very simple.
That takes this data and over the post variables and just creates entries in our data store. So very simple code to write, probably 20 lines or not much more than that. We get all the data into the App Engine data store, and it looks something like this. We can see it's maybe a little small for you to read, but we have data like the air temperature, the altitude, which the device actually collects from the GPS in my phone, the altitude, latitude, and longitude. We also have the RPMs, how fast the engine is going, the speed of the car, throttle position, the time, all sorts of interesting bits of data, and you can configure what types of data you want to upload. There's plenty more properties available. But we all get this into the App Engine data store, and the App Engine data store is a great place to collect this data and maybe build a simple web front end on top of it. But if we want to do analysis, let's say we're extending this beyond just my car, and we want to do an analysis on a fleet of 10,000 cars or something like that, we really need the power of something like BigQuery. So we want to get this data into BigQuery.
Right.
So how do we do that? Well, there's a trusted tester feature, which will give you a URL here shortly that allows you to sign up or apply to be in this trusted tester program. But this trusted tester feature allows you to get data from BigQuery over to, from App Engine, the App Engine data store, over to BigQuery by doing a backup of the data store and storing that backup on cloud storage. That's the first step. It's really a simple two-step process. So the first step is backing up that data. We can see here I specified my cloud storage bucket called car data and said that I'm doing it on cloud storage. And let me just talk a little bit about the permission system here quickly, because Michael has been asking me about this, how that works. The permission system is really simple. App Engine has a application identifier role account that the App Engine app runs under. And you can find that, is it the application info tab or something like that in the App Engine console?
Yeah, there's an application setting tab that has all of this information.
Yeah, and so you grab that email address and you can put that account into a project. So we went over to the APIs console and set the project to be writable by that particular email address, and that's how we granted the permissions. You can certainly do that also within BigQuery as well, and within the cloud storage. They all have the same way of doing permissioning on these accounts. It looks like a regular user account. So we gave permission for the App Engine app to write to cloud storage, this bucket called car data. And then if we go over to cloud storage after we do the backup, we can see all the backup files within cloud storage. So we see here at the top there's this torquedata.backupinfo. That's the torque data is the name of our entity in the data store, and the backup info file is kind of the metadata file that describes my backup. I then take that and use BigQuery to, I point BigQuery at the URL or the cloud storage URL for that backup info file, and just tell BigQuery to import that table from cloud storage. So this is showing the UI way of doing it. We can also programmatically do all of this. So you can programmatically schedule cron jobs to allow you to back up the data on a scheduled time period, and you basically are just putting in the different parameters that you would put into the UI in your cron job as parameters when you call out to make the backups. And in addition to that, then of course programmatically you can also import this data from cloud storage into BigQuery. But that's the basic steps here. So all we have to do is get the data into the App Engine data store, get the data backed up from the data store over to cloud storage, and then BigQuery imports it from there. And of course, we're going to try to make this a smoother process for you as well, but it is really a simple 2-click process that you can do and then automate using the cron job feature. So if you're actually interested in testing out this feature, the feature that allows you to move the data from the App Engine data store over to BigQuery, you can see this URL here. I'm going to leave this up for a moment. This allows you to apply for the Trusted Tester program. We're looking for people who have some interesting data in App Engine and are looking to analyze that data sort of for large-scale aggregate queries and ad hoc queries on that data in BigQuery. We have some interesting people who have signed up so far and have used it for a wide variety of different types of data, but we're always looking for more to get more and more of your feedback. All right, so we've talked about how we get the data into BigQuery. Now let's talk about actually querying the data. The interesting part isn't getting the data there, it's actually running some queries. So I'm going to show you a couple queries here that we've run. The first query is looking at, and I made this a little bit large it looks like, but looking at the average speed that I drive in San Francisco. So we can see here the average, rounding the average speed. It's stored in kilometers per hour, and then we're converting it to miles per hour. And we're doing it from our latest dump, which is on 2012, 1203, which I think is today. And then if I can scroll down here a little bit, we're looking at the particular latitude and the particular longitude.
So this is a bounding box around San Francisco, roughly, right?
Yeah, this is a bounding box around San Francisco. So I wanted to see when I'm in the city, how fast am I driving in the city? And I think that varies a little bit from when I'm on the highway. So let's query here. And we can see here my average speed in the city is 47 miles per hour.
That's pretty fast, right?
Yeah.
What have you been doing?
So I don't drive that fast, Michael, on city streets. I think the speed limit on city streets is like 25 or 30 miles an hour on most of the city streets. So I don't drive at 47 miles an hour. But we do have highways in the city that go on and off of the Bay Bridge as well as go down to the peninsula. So that must have been my speed on the highway. I will swear to that. All right, but now what is my speed when I'm outside of San Francisco? If I'm not looking at the bounding box for San Francisco, how fast am I going?
So San Francisco is a pretty dense city. When you get out of the city, you expect to probably go a little faster because you're on the highway.
Yeah, probably. Let's take a look at what this speed is. All right, so here we have average speed on the peninsula, which is doing a similar thing, but then we basically have different latitude and longitudes here. And I'm also, and we're not seeing this on the screen, but I'm also filtering out those times where the car miscalculated my speed and thought that I was over the speed limit, because that doesn't actually happen. So I'm filtering those out. Let's see how fast I'm going here. All right, so we went from 47 miles an hour to 54, right. A little bit faster. Not as fast as I would think, as much, faster as I would think. And I think that's probably because of mornings like this morning where we're crawling at 10 miles an hour.
I'm surprised you can even go that fast on the 101.
Yeah,
I happen
seriously.
to know you try to beat rush hour, though.
Anyway, but these are the types of queries that you could run, and you could also run all sorts of other queries on like the RPMs and figuring out what your speed was at various RPMs and things like that. Figure out how well your car is running. But imagine if you're running it not just on my, I don't know, 100,000 records I think I have here, but you're running it on a much larger data set of a car that drives much more often and maybe a whole fleet of 10,000, 20,000 cars.
Imagine what you can do is you can find anomalies in your fleet. And this doesn't just have to be cars. It can be sensors of any kind, right? Imagine if you have servers and you're looking at logs and you want to find anomalies in those logs. You can do that with BigQuery using datastore for what it's good at, which is being highly available and very high performance to rapidly collect data. And then using BigQuery to actually do aggregate queries over that datastore data.
Yeah, so right now we're actually collecting this data through this Torque application that we talked about. We do actually have this goal of using other parts of the platform. I'm going to just skip back here quickly to the diagram here. So we have this goal of, on the Android phone, using the Cloud Endpoints feature that we announced at Google I/O. And the Cloud Endpoints feature allows you to use our API infrastructure in order to write your applications, have APIs for your applications. And it's particularly valuable in the mobile use cases. So imagine here if I'm able to get the data from the Bluetooth sensor directly, write my own application, and upload it to App Engine. I have a little bit more control over it then. And what I mean by control is right now the application, which is awesome, that's running on my phone, this Torque application, that application is collecting data points a few times every second. And for each of those few times every second is making a request over to my App Engine app and posting that data. But with the Cloud Endpoints implementation, what I could do is actually use the batch functionality, or just batch them up myself manually and say post 10 or 20 of these at a time. And so basically, not have to make a few HTTP requests every second, but rather, once every 10 seconds or something like that. So we can optimize it a little bit. And then that'll be a great example once we're able to do that to demonstrate how you might collect other sensor data from your phone or other wireless devices and upload it to App Engine. And then eventually to BigQuery for analysis, of course. All right, so let me start down here. Apparently I clicked a bit of the wrong button. And
all right.
Michael.
Yeah, so we're going to do something a little bit different today. We're going to look at some of the great community questions from our Stack Overflow tag, which, as I said earlier, was Google-BigQuery. So Ryan, myself, members of the BigQuery engineering team read every single question. We take your developer feedback very seriously, and we love the thriving developer community that's growing up on Stack Overflow in relation to BigQuery. So I'm going to read some of my favorite questions from the past week and actually talk to people about them. I think they're very useful questions for everybody developing with BigQuery. And so let's just dive into it. The first question that caught my attention was, is it possible to join Cloud SQL tables to a BigQuery table? So the answer is not directly. So Cloud SQL is basically a MySQL implementation that you can access through Google App Engine. It's very powerful, it's very useful, but the question was, can I do a single select statement that incorporates a BigQuery table with a Cloud SQL table? So the answer is not directly. You can't write a single SQL statement that can query both at the same time, but you can use the data from Cloud SQL in a query for BigQuery. You just need to export that data and import it into BigQuery, much as we described with the App Engine data store import that we were talking about earlier. Actually, there's a way to export data from Cloud SQL, and the way you would do that is export the data into a CSV format, then import the data back into BigQuery, and then run your join statement. You can actually join two tables together, and that's basically how you do it. We don't have a direct pipeline like we do with the data store data, but I appreciate this feedback, and it's something we'll definitely look into.
And I do want to say, though, that this is something that you can do, not just with Cloud SQL, but with any, relational database or other data source you have, because BigQuery can ingest your data in either CSV or a JSON format. And we do have a lot of customers that, BigQuery is for analysis. We have a lot of customers that, of course, need sort of an authoritative data source in a relational database to store their data in. And then, every now and then they take that data out and put it into BigQuery, maybe in sort of a nightly cron job, similar to how we did with the datastore backup. So it's a very useful pattern to get accustomed to.
Definitely. And like Ryan said, if you're using a document store, you can use the JSON import to get data into BigQuery. And if you're using a relational database, of course, CSV is a great format for that. So great. So the next question I see all the time, and I wanted to talk a little bit about it today, authorizing access to Google BigQuery via API key. So the question basically is asking, as some Google APIs do, can I use an API key to authorize access to BigQuery by basically appending a key value to the end of a request to the BigQuery API? The answer is actually no. BigQuery does not support API key access. But oftentimes, when you're trying to do a request that is something that you could use API access for something else, API key access, what you really want to do is use a service account authorization flow. And so we have a lot of great documentation about how to build this, both on an installed application or an App Engine application. But basically, this gives your application the authorization to make calls to the BigQuery API on your behalf. And so we have lots of documentation about how to do this. But if you are interested in using an API key type authorization method, you probably want to try out service account authorization instead.
Yeah, and this uses a standard sort of OAuth 2 flow, and it's the same thing with BigQuery as with a lot of our other APIs. Just wanted to insert a reminder here. If you do have questions live, you're listening to this live, make sure to head out over to our moderator and ask questions there. So you can go to developers.google.com/live and click on this episode, and you'll see the embedded moderator there. And we'll keep on jumping in through some Stack Overflow questions.
Yeah. So let's take a look at actually two questions, but they're related, and they're actually from the same poster. The first is maximum number of nested records and the cost of querying those records. So let me try to explain. BigQuery supports two types of data models. One is flat records, meaning a record with fields that are flat, and the same for record to record. But we also support nested and repeated records, meaning a single field within a record can have children records as well. So the original question was how many levels of nesting can we support? The answer is actually 100. We support nesting levels of 100. And if you actually are using a data model like this, I'd love to see it. I'd love to see what you're doing. But you can imagine like how useful that is, right? Like you could actually have, for example, a person class, and under that record, you could have their age and their first name and their last name, and you can actually nest that. You could even say, in this example that I'm showing here, the cities they lived in. And this can be a different amount of cities for every single record, and it can grow or shrink depending on the person. And so it's very useful, very easy to model. A lot of non-relational databases already model their data like this. So BigQuery supports that. So we can support up to 100 nests of records. But the other question was the cost of querying. And so if we can skip to the next slide, this highlights how BigQuery actually stores the data. So what's really interesting about BigQuery is we take all of your data from row-oriented storage, and we store it in column-oriented storage. And the cool thing about this is when we have nested records, each one of those records gets its own column. So for example, if we go back to this example for the cities that people lived in, here you can see there's a person record, and underneath it, it's the city and the years that they lived in. We store each of those values in their own column. So the cities will all get their own column, and the years lived will get their own column as well. For BigQuery, we charge for processing only what you ask for. So if you actually just want to know, say, the average number of years lived in any city, and only ask for that column, that's the only column we're going to look at. We're not going to touch other other children columns in that query. So actually, it's very, very economical, and it's a very good way to model your data. So.
And if you want to read more about how we deal with nested data in BigQuery, the Dremel white paper actually provides a lot of interesting academic knowledge of how we do that. So look up Dremel white paper on the web, and it describes how this nested structure works and how we're able to still achieve the performance that Michael talked about. The one other thing we should mention, though, in terms of the nested data, is that each of your kind of parent records still needs to fit within the 64 kilobyte row limit. So You can't have you can have what I think 1,000 is what you said nested underneath it,
100, but
or 100. But there is a limit in terms of the amount of data that you can have stored in there. But if you ever get an opportunity where you're hitting that limit, definitely reach out to us and let us know that you're hitting that limit and allow us to take a look, because there might be some things that we can do either now or in the future to raise that.
Great. So let's just check our moderator page and see if there's any new questions. There doesn't seem to be any BigQuery questions here, but let me refresh.
There's one.
There is one. Okay. This is a great question. The question is, will it be possible to import only the chain sets of data from App Engine? Full data store dumps can be quite large and time-consuming to perform. That's a great question.
Yeah, so I'm curious whether Scott has actually been in the Trusted Tester program. If you are in the Trusted Tester program and trying it out, we're going to be reaching out and looking for your feedback soon. Definitely send us that one and what your use case is. That definitely is a great feature idea for this functionality and something that I would argue for us to implement. Right?
Yeah, I think it's a great question.
So that's the only question right now. We'll give it another second here if you have any additional questions on Google Moderator. Otherwise, we'll let you guys head home early. I think on the West Coast here, it's 4 minutes before 5. So
it looks like that's it. There's no new questions on the moderator.
All right. Well, thank you, everyone, for joining us today. I'm Ryan.
I'm Michael.
And this is the Ryan and Michael Show. Take care.